All right, we're comparing additive and multiplicative patterns. The sequences below are either additive, arithmetic, or geometric. Identify the type of sequence and fill in the missing values of the table written as an equation. So looking at this first one, do you see that it goes from 2 to 4, 4 to 8, 8 to 16, 16 to 32, much like the task we did today? So this one is just multiplying by 2 to get to each step. So 32 times 2 to continue it. 64 times 2 is 128. 128 times 2 is 256. So this one would be the type of sequence would be geometric. And the equation we would write for this would be a sequence that begins with 2 and is multiplying by 2 to the n minus 1 power. So we're using this first term here in the equation. We're using this output as our starting value, and we're using the times 2 right here as this 2. So that's how I built my explicit equation. Next, let's look at this one. It goes from 66 to 50 to 34 to 18. Do you see what's happening in that one? You got it. It's just subtracting 16. When we're repeatedly subtracting something, we're going to be doing an arithmetic sequence. And the equation for this one begins with 66 and is repeatedly subtracting 16 n minus 1 times. There's our first term. There's where 66 shows up, and then the minus 16 comes from the repeated subtraction. So 18 minus 16, or 16, you know what I mean. And then 2 minus 16, we get into the negatives here, and then minus 16 again, and then minus 16 again. All right, so that's an arithmetic. Here we go on the next one. -3 to 9, 9 to -27. Notice that it's alternating between positive and negative here. So that's kind of a hint that you should be thinking about a geometric sequence, because this time our multiplier is a -3. So our equation begins with -3 as this output beginning number, also multiplying by -3 each time to the power of n minus 1. Because it's repeated multiplication, it is an exponent. So 81 times 3, we've got the negative appearing again. This one's going to be positive, this one's going to be negative, this one's going to be positive. Times 3 again, times 3 again, times 3 again. All right, down here from, looks like we're having, right, 180 to 80 to 160 to 80 to 40 to 20. So this one is also a geometric. Half of 20 is 10, half of 10 is 5, half of 5 is 5 halves, or 2.5. Half of 2.5 is 1.25, or 5/4. The equation goes like this, begins with 160, multiplying by 1/2 each time to the power of n minus 1. All right, we're going -9, -2, -2 to 5, 5 to 12. Do you see that it's just adding 7 each time? And so this one's going to be arithmetic. And the explicit is f of n, begins with -9, adding 7, n minus 1 times. Okay, so that's just a review from Math 1 of arithmetic and geometric tables and how to write an explicit from it. Now we're just going to do a couple quick graphing questions. So the first question is, what's f of 2? That means that x is 2, right? So there's a 2 in place of the x. So I'm going to go find on the graph. I'm going to go out 2. So out 2, and I'm going to look up to where my graph is at that point. So 2, 2 is the coordinate pair. So when they ask for f of 2, my output is also 2. Where is f of x equal to 4? When it gives me the output this time, I go up to the y-axis and look out across from the 4. So when the output is 4, what's my input? Also 4. Why would they have made this all the same numbers? That's going to be kind of annoying. Find the value of f of 6. So I go out to 6, look up to my table. This time 6 matches with 8. And where is the output? 16. So I go from 16 this way, follow it down. 5, 6, 7, 8. And you can write your answer as x equals 8 or just f of 8 equals 16. What do you notice about the way the inputs and outputs for this function relate? Create an in-out table if you need to. So 2 to 4, 4 to 4, sorry, 2 to 2, 4 to 4, 6 to 8, 8 to 16. Did you notice that it was multiplying by 2? At each step. Let's write an explicit for this function. The function begins right here at 1, multiplying by 2 to the power of n. You also could have written this function using any other input-output pair like 2, 2, 2 times 2 to the power of n minus 2. So that would be using this coordinate pair right here. All right.